Hi guys, Miss Griffin. We're looking at Unit 4, Skill 4, Powers of I and Complex Numbers. So here's your essential question. It says, how do we simplify powers of I? So remember, I is the imaginary unit. We learned about this back in 4.1 with the square roots of negative numbers. Turns into an imaginary number. And then the second question is, how can we add and subtract and also multiply complex numbers? So complex numbers are numbers that have an I in them. Okay, so an imaginary unit in them. We can actually ignore these calculator settings that are off to the left because you can type in i's no matter what. So unless your calculator is not a TI Nspire, then you might need to put it in A plus BI form. Okay, so if you don't have a TI Nspire, you let us know and then we'll help you out with that. So the first thing we're going to do is talk about powers of I. So starting with this I to the first, you guys know that this is equivalent to the square root of -1. That's how we end up getting just I. Then if we have I squared, that means do square root -1 times square root -1, which is the same as square root -1 squared. Well, square root -1 squared is just -1. Because the square and the square root cancel. If we have I to the third, that would be 3 of those square root -1s, which results in a negative I, because this makes a -1 times this, which is I, so a negative I. Okay, and then we have I to the fourth would be 4 of them, holy moly. Square root -1, square root -1, square root -1, square root -1. And we know the first 2 would multiply to make a -1. Second 2 would multiply to make a -1. -1 times -1 is +1. Okay, so we have this thing that is a cycle. If we have I to the first, we get I squared is -1, I to the third is I to the fourth is 1, and then we repeat. We go back to I, then -1, then I, then 1, so on and so forth. Okay, so it's cyclic. That's what this little picture is showing you. Okay, it goes around like a cycle. We have 1s and -1s along the x's. So the real numbers are x's. The i's, the imaginary numbers, go along the y's. Okay, so keep that in mind. It's very rare that you're going to have to use that, but just keep it in mind. Now, for example 1, we have to simplify this stuff. And so all of these are all over. Okay, so example 1 says simplifying. We need to figure out what I to the 17th is equivalent to. Now we could continue doing this cycle over and over and over and over and over until we get to the 17th, but holy cow, who wants to do that for 203? Now these are the real steps to do it by hand. However, your calculator is super handy and can cheat this. We can literally type in I to the 17th and get an answer, so I'm going to show you how to do that right now. Alright, so the first thing we're going to do is type in I to the 17th. So at the bottom of your calculator in the pi button, so again, hit the pi button, you pull up this little menu and we're going to choose I. And then we need to raise it to the 17th. So to raise it to a power, we hit this little caret button next to the x squared, and then I type in 17, hit enter. And it gives me I. Okay, so now we're going to try the next one, I to the 54th. So again, hit the pi button, bring up your menu, choose I, caret 54. Gives us -1. And then when it says I to the 203rd, again, I hit the pi button, down here by the H, choose the I, and caret 203, -I. So it's as if we're doing that cycle way up above and repeating it until we get to 203. Okay, and then I to the 152 is +1. So we'll talk about number 5 in just a second, but let's jot these down. Okay, so for number 5, this could show up as like a little short answer question for you, and you've got to be able to show your work. So these first 4 are very simplistic. You just type them into the calculator. There's nothing more to show. However, this one, you want to break down into each individual piece. Okay, so we're going to first find out what 5I to the 16th is, find out what 3I to the 23rd is, and then find out what I to the 26th is. So I could show you this again in the calculator, but if you want to watch the calculator steps, you can just go back, rewind to that video. So we know that this is 5 times something, and that something comes from our calculator, which ends up being 1. And then this is plus 3 times something, and that something, again, from our calculator ends up being a negative I. And then this is plus something, which is in our calculator negative 1 when I plug in I to the 26th. So from here we just have to simplify. This gives me 5 minus 3I minus 1. And then we want to combine any like terms. So 5 and negative 1 can combine to become 4, and then of course carry along the minus 3I. Okay, so sometimes you can do this as a multiple choice question and just type the whole thing in. Other times you might have to show your work, which is this piece here. All right, moving on to the next page where we're going to learn how to add and subtract with complex numbers. All right, so first let's talk about complex numbers. They are a combination of a real number with an imaginary number and will be of this form, a plus bi, where a and b are real numbers, and then of course I is the imaginary unit. So a is the real part and bi is the imaginary unit of that entire number. The two parts, the real and imaginary, cannot be combined. So it would be as if you had a 3 and a 4x. You cannot combine them. And then like real numbers, complex numbers may be added and subtracted. The key to this is that the real components can be combined with real components and then imaginary with imaginary. So we want to make sure that we are combining like terms here. So in this first example, it says simplify 5 plus 8i minus this whole entire quantity. So of course your first step is to distribute that negative. So now we have 5 plus 8i, and we can drop parentheses at this point, minus 2 minus 2i. So then you're going to find your little like terms here. We have a real, an imaginary, and an imaginary. Okay, so we just combine the real stuff together and combine the imaginary stuff together. So 5 take away 2 for the real component is 3, and then 8 take away 2 with i's attached is negative or positive 6i. 3 plus 6i is how that would combine. Next one, we've got combine these two expressions. There's a plus sign in the middle, so plus does not mean we need to distribute. We just write it down, drop your parentheses. We want to find like terms, so this is a real component, this is a real component. There's no i's on it. And then these two are both the imaginary parts, so those get combined. Notice how this has an x and this has an x. That's important to make sure that they both have the x's, because if they didn't, we could not combine them. All right, so 6 plus 3 here is 9, and then 4xi plus 7xi is 11xi. And then, of course, box it in for your answer. Next one, we need to express the sum in simplest a plus bi form. So in order to do this, we've got to first break down those radicals. All right, so I'm going to do this one first. Sum means add, so we have 3 plus. Now, you know the square root of positive 64 is just 8, and then the square root of that negative turns into an I. Okay, so that should be easy enough for you to think about. 3 plus 8i. And then we need to put a big plus for the sum of 10 minus square root of negative 25. So 10 minus square root positive 25 is 5. And then the negative under the square root turns into an I. And then combining like terms. So 10 plus 3 is 13. And then 8i minus 5i is plus 3i. And it's in simplest a plus bi form, where we have our a term and our bi term. All right, the next one says subtract this first thing from the second thing. So be careful how you write this. Subtract this from this. So the 7 plus square root negative 45 has to come first. And then subtract means obviously subtract. And then the second term, negative 9 plus square root negative 80. Okay, so we're going to do a little bit of work here. We've got 7. I'm going to do this one first. 7 plus radical, radical, radical. because when we have a negative under it, we need a negative 1. Okay, so then 45, if I type it in my calculator menu number factor, we get 3 squared times 5. So 3 squared is the nice piece, 5 is the leftover. Okay, so we're going to keep simplifying this. We have 7 plus, this turns into a 3, I square root 5, because this becomes I. Square root negative 1 is I. And then we have minus this stuff. So we have to distribute the negative. So it becomes plus 9 minus square root, square root, square root. The last square root is that negative 1 because the negative gets pulled out. And then 80 in my calculator, menu number factor, gives me 2 to the 4th times 5. When it's an even power, I can take it 2 to the 4th and then 5 to the 1st. Goes in the leftovers. So we have plus 9 minus this piece turns into 2 squared, I, because of this, and then square root 5. So from here, we're just going to simplify. We have 7 plus 9, like terms here, to give us 16. And then this is an I with a square root 5. This is an I with a square root 5. So those can be combined. But first I need to know what 2 squared is. 2 squared, of course, is just 4, so I can actually change that to be a 4. Make my life a little bit easier. So then it's 3i square root 5, take away 4i square root 5. So that's negative 1i square root 5 to be our final answer. Okay, so break down radicals before you can combine. Let's flip it over and learn how to multiply them. All right, so we're going to read this little blurb here. It says, adding and subtracting complex numbers is pretty straightforward because the process is similar to combining algebraic expressions that have like terms, right? So adding and subtracting, you can combine like terms, and it results in a complex number because it's closed under addition and subtraction. So we've got this question, is multiplication closed? Will we always result in a complex number? So let's do our first example and some later examples to find out if it's always closed. Okay, so we've got 2i times this whole entire quantity, so we're going to distribute. You always want to distribute when you have a pair of parentheses with something in front of it and you're trying to simplify. So of course 2 times 3 becomes 6 with the I attached. It's just as if it were an x, however it's not an x, it's an I. And then the next part, 2 times 3, is again 6, but I times I gives us I squared. And if you recall, we said I squared is equivalent to negative 1. If it gets typed into your calculator or if you remember the little cycle. So we want to replace I squared with negative 1. All right, so the 6i stays the same, plus 6 times now negative 1. And then we have to write our final answer in the order of a plus bi. So this gives me my real part, so that's negative 6. And then the bi part is plus 6i. Those are 6's, not b's. Okay, so 6. We're going to skip number 2 for now because we'll see another example like that in just a bit. And we're going to look at number 3. Number 3 has this whole quantity squared, so that means write it out twice. 3 minus 5i times 3 minus 5i. And of course you know that you should double distribute. So 3 times 3 gives us 9. 3 times negative 5i is negative 15i. Negative 5i times 3 is, again, negative 15i. And then negative 5i times negative 5i is positive 25i squared. But you know that I squared is something special. This gets replaced with a negative 1. And then, of course, you want to combine any like terms. So I carry down my 9. I now have negative 30i. And then I have positive 25 times negative 1. So that's a negative 25 that's getting carried down. Okay, and then still combining like terms, 9 minus 25 is negative 16, and then minus 30i. Number 4, same idea. You're going to double distribute. 5 times 2 is 10. 2 times negative 2i is negative 4i. Right here, don't be scared, it's just positive 10xi. And right here is negative 4xi. x, and then I times I gives us that I squared. We're going to combine any like terms, but then again, any I squareds get replaced with a -1, and it's multiplying, not subtracting. Okay, so 10 gets carried down. These two terms are very different from one another. They cannot be combined. Okay, so minus 4i plus 10xi. And then this over here is -4 times -1, so that's +4. And then combining any like terms that we have, 10 plus 4 is 14, minus 4i plus 10xi. Ooh, trying to make that a little curvy. All right, number 5 is going to be our last one. Number 6 is very similar to the one we just did, number 4. So number 5 right here. Double distribute. Same old, same old. 4 times 4 is 16. 4 times -2i is -8i. 2i times 4 is +8i. 2i times -2i is -4i squared, just like x times x is x squared. All right, combining any like terms, but also remembering that I squared changes to be multiplied as a -1. So -8 plus 8 with an I attached, they both just cancel. Now we have 16 minus 4 times -1. So 16 plus 4, which is just 20. Final answer is 20. So right here we can see that multiplying complex numbers is not closed. Because again, we did not result in a complex number in the end. All right, so don't forget to write your summary. We don't have your little prompts here, so I can give you a couple little prompts. Let's talk about how to determine I to a power in your calculator. So like I to the 83rd is equivalent to blank. How would you do that, right? And then let's also talk about something super special. I squared is equivalent to something. It always gets replaced with what? And then when you are combining like terms, you should combine this and combine that. So combine constants together, which are your real things, and then combine I terms together. So that it's always in that A plus BI form. Okay, so finish up your summary and then go to your practice problems. Let us know if you have questions.